waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 8.5. We're going to look at properties of trapezoids and kites. These are both quadrilaterals, but they're special types of quadrilaterals. So the first one is a trapezoid, which is a quadrilateral with exactly one pair of parallel sides. So in this trapezoid, that would mean this is parallel to that. I'll go ahead and label this trapezoid A, B, C, D. So AB is parallel to CD, and BC could be parallel to AD, but that's not necessary for it to be a trapezoid. Along with those sides being parallel, we also need to make sure we understand the lingo here. AB and CD are the bases. The sides that are parallel are called the bases. And in the trapezoid, there are two pair of base angles. So angle C and angle D are base angles. And angle A and angle B are also base angles. Those are the two pair of base angles. The other two sides, the non-parallel sides, are called the legs. So AD and CB are the legs. In an isosceles trapezoid, the legs are congruent. So if these are the sides that are parallel, then that would mean that these legs are congruent. And if the trapezoid is isosceles, then each pair of base angles is congruent. So I know this is parallel to that, and I've identified that those are congruent. That makes it an isosceles trapezoid, which means that angle is congruent to that angle, and this angle is congruent to that angle. So the pair of base angles are congruent if it is isosceles. Now, what if it has a pair of congruent base angles? So just one pair. So for instance, if that is congruent to that, and we know that this is a trapezoid because these are parallel, then you can conclude that those two legs are congruent. Remember, these are called the legs, and these are called the bases. A trapezoid is isosceles if and only if its diagonals are congruent. So if we have an isosceles trapezoid, then that means that that diagonal is congruent to that diagonal. So AC is congruent to BD if and only if it is isosceles. If a trapezoid is isosceles, then the diagonals are congruent. If the diagonals in a trapezoid are congruent, then it is isosceles. That's the two ways you can say that. The midsegment theorem for trapezoids says that the midsegment of a trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. So remember, the midsegment connects the midpoints. So this would be our midsegment, FG, which means that that's congruent to that, and this is congruent to that. F and G are the midpoints of the legs. F and G are the midpoints of the legs. So FG is parallel to AD as well as parallel to BC. FG, meaning the distance of FG, that's what that means there, is equal to 1/2 AD plus BC. So take a moment and look at that equation, see where I got that from. The midsegment is half the length of the sum of the bases. That's the sum of the bases. Moving on to a kite, it's a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. So in other words, this is congruent to that. Those are consecutive sides. And these two are congruent to each other, but again, not congruent to the other two. If a quadrilateral is a kite, so if this is true, then its diagonals are perpendicular. Where's the diagonal? Here's one diagonal, and here's the next diagonal, which means it's going to intersect at a right angle. Also, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So congruent, congruent, these are congruent to each other. So if I show that that is congruent to that, then, let me see. So if it is a kite, then those angles would be congruent. Those are the properties of trapezoids and kites. You'll need to know them in order to identify if something is a trapezoid or a kite, and then also to solve problems using trapezoids and kites.
I've been waiting way too long.